Welcome to the deep dive. Today we are strapping in for maybe the biggest question humanity has ever faced. Are we alone? But we're not just talking philosophy here or, fringe ideas. We're drilling into your source material hard scientific data about objects visiting our solar system. Objects that seem to, well, defy easy natural explanation. And we'll also look at the resistance scientists face when they suggest these things might be artificial.
Exactly. And what's really fascinating with sources is this core paradox. You get these interstellar objects, these eyes objects, and they show behavior that just breaks the known rules for comets or asteroids. But the default response from, let's say, the establishment, it isn't really curiosity first. It's often to invent these incredibly complex, sometimes totally unproven natural explanations. A dark comet, some exotic chemical pathway nobody's ever seen, anything but confronting the possibility of ET, extraterrestrial technology.
That seems like a huge hurdle. Intellectually, I mean. Let's unpack that right away.
Yeah.
Starting with the second big visitor the sources focus on, 3I Atlas. That name, 3I. It just means it's the third confirmed interstellar object we've spotted, right?
That's correct, yes. And the sheer scale of 3I Atlas.
Yeah.
It makes it hard to just wave away as a random bit of space ice.
Yeah.
Based on the analysis, my calculations show this thing is incredibly massive, around 33 billion tons, which translates to a diameter of, well over 5 kilometers.
5 kilometers, wow.
Yeah, it's so big that any idea this was faked or some kind of distraction, it's just nonsensical. It's visible enough that you could actually track it with a decent amateur telescope, like a half-meter one.
Okay, so we know it's real, it's there, and it's gigantic. If it's not a hoax, where does the data start to really push the boundaries of what a normal comet should be doing?
Right, well, first let's look at the propulsion puzzle. A key piece of data is its trajectory. We know 3I Atlas is losing mass. It's venting gas something like 150 kilograms every second. And the composition of that gas, it's highly unusual. About 87% carbon dioxide, CO2, only 4% water, the rest mostly carbon monoxide.
Wait a second. Isn't a typical comet plume mostly, well, water from sublimating?
Precisely, yeah, overwhelmingly water. So the composition itself is already strange. But here's the really big physical problem. If it were a standard comet, propelled by that gas venting, Newton's third law demands that mass loss would create a noticeable recoil, a push. It should shift its path away from a purely gravitational trajectory. But 3I Atlas, its motion is sculpted only by gravity.
So no push from the gas.
Apparently not. Its calculated mass, that 33 billion tons, is just so enormous it completely dampens any expected recoil, which means this object must be incredibly dense, or maybe very robustly constructed.
It sounds less like a snowball and more like something engineered for stability.
It does hint at that, yes. And the data gets even weirder when you look closely at the material it's actually shedding. Analysis of that gas plume. It shows high levels of nickel, but very little iron.
Nickel without much iron.
Right. Here on Earth, that specific nickel-heavy ratio is characteristic of specialized alloys, things we manufacture for aerospace. It's not the kind of ratio you typically find in natural meteorites, chondritic rock.
Okay, so on one side, you've got a chemical signature that almost screams man-made, or at least tech-made alloy. What's the counter-argument? How do they explain that naturally?
Well, the scientists who want to stick with a purely natural explanation to avoid the whole ET thing, they've suggested this unproven mechanism. They call it a carbonyl pathway.
Carbonyl pathway.
Yeah, it's a theory. It suggests some kind of strange hypothetical chemical process deep inside the object could create this weird ratio of materials. Without any technology involved. The problem is we have zero observational evidence this process actually happens in nature. None. It feels a bit like theoretical camouflage, really, designed to protect the status quo thinking.
And this is where the visual evidence comes in, right? You mentioned an anti-tail observation. Explain that, because it sounds like it violates physics.
It does sound like that.
Yeah.
So a normal comet tail, it's dust and gas pushed away from the sun, solar radiation pressure, solar wind, right? But an initial image from Hubble back in July 2025, it showed this clear glow, maybe a jet, pointing towards the sun. Not away.
Towards it?
Yes. Yeah. Elongated in the exact opposite direction you'd expect from standard physics. We started calling it the anti-tail because it was just fundamentally contrary to what we thought we knew.
Okay, so let's connect the dots. We have this incredible density or robustness, the weird alloy-like composition, this sun-pointing anti-tail. And the sources also highlight its trajectory as being highly suspicious.
Yes, very much so. 3I Atlas is moving retrograde opposite to the direction the planet's orbit, and its path is unusually aligned very closely with the plane of the planets. within about 5 degrees. Now, that specific trajectory, it's described in the sources as pretty much ideal if the object was designed to, say, release mini probes
Yeah.
towards the inner planets, perhaps Mars or Jupiter.
And then there's the final piece, this almost unbelievable cosmic coincidence. Its arrival direction lines up with the famous WRW signal from 77.
And that alignment is, well, it's astonishing. The arrival direction of 3I Atlas was within just 9 degrees of the direction of the WOW signal. And remember, the WOW signal was the strongest, clearest potential SETI signal ever detected. Never repeated, never explained. The calculated probability of that alignment just happening by chance, only 0.6%.
Tiny.
So when you stack all these improbable things together, the lack of recoil, the nickel signature, the anti-tail, the specific retrograde path, the WRW alignment, suddenly the purely natural explanation starts to require more extraordinary assumptions than the technological one.
This really echoes what happened with the first object we encountered back in 2017, doesn't it? Oumuamua. That was the first officially acknowledged AIO anomalous interstellar object. Just remind us quickly what made that one so strange.
Right, Oumuamua. Well, it was shaped, bizarrely, like a flat pancake or maybe a cigar, depending on interpretation. And it was the very first object we saw getting pushed away from the sun by some non-gravitational force. But critically, just like Atlas seems to be, it showed absolutely no sign of cometary evaporation. No gas, no dust, no visible tail.
But it was accelerating away.
Exactly. So experts dubbed it a dark comet, which to me is shorthand for calling it a zebra without stripes. It acts like a comet because it accelerates non-gravitationally, but it completely lacks the defining visual feature of a comet, that tail. The pattern seems clear. When data resists the standard comet model, it just gets a new, unproven cometary label slapped on it.
Okay, so if the data is this compelling, maybe the issue isn't really about physics anymore. Maybe it's psychology. Why are people, especially in the scientific community, actively resisting this data, even when the stakes seem so incredibly high? That brings us to this idea of the black swan event and maybe the cultural baggage within academia.
We absolutely have to consider the implications of a black swan event. You know, something with a low perceived probability, but potentially world-altering consequences. I draw a parallel in the sources to intelligence failures, like the October 7th example, where Israeli intelligence seemingly dismissed incoming data because they were locked into a comfortable theory that Hamas wouldn't act that way. The result was catastrophic.
So you're saying, even if the odds of an ET visit seem low to some, the consequences of being wrong, I mean, they change everything, right? Financial markets, politics, our whole sense of self, that we're basically obligated to investigate it seriously.
Absolutely. It's like Pascal's wager, but applied cosmically. The potential implications of being wrong about finding alien technology are just too enormous to ignore, regardless of what we think the probability is right now.
But the standard defense from academia, the pushback you hear, is that the claim itself that we are being visited is so extraordinary that it demands truly extraordinary evidence.
And I argue that that very argument is rooted in a kind of flawed human hubris. Let's be really clear about this. The existence of other technological life out there. That should be considered an ordinary claim, not an extraordinary one. We have hundreds of billions of sun-like stars just in our galaxy. Many formed billions of years before our sun even ignited. Billions of Earth-like planets in habitable zones. To suggest that we, on this relatively young planet, are the very first and most accomplished spacefarers in cosmic history, that's profound arrogance.
Okay, but isn't the claim that they have actually visited Earth the really extraordinary part? Are we maybe conflating the existence of life elsewhere with them actually coming here?
That's a fair distinction to make, yes.
Yeah.
But the anomalies presented by objects like Oumuamua and now 3I Atlas, they demand that we investigate the visitation hypothesis with the exact same scientific rigor we apply to trying to find natural explanations. And the current culture, well, it really doesn't allow for that level playing field. This resistance often comes down to, frankly, a fear of ridicule, career risk, and that directly impacts funding.
You highlight a pretty significant funding bias in the sources.
Oh, yes. The scientific community's main priority right now, finding microbial life. They're allocating over $10 billion for a Habitable Worlds Observatory, which is great science, don't get me wrong. But at the same time, they recommend zero, absolutely zero federal funding for the systematic, organized search for intelligence, for ET technology. I call that a fundamental oversight. We really should be hedging our bets, Searching for technology which might actually be easier to detect across vast interstellar distances than microbes should be treated as a major scientific frontier.
It sounds like a deep, almost cultural resistance. You connect it back to history, like with Galileo. We waited, what, 350 years for the Vatican to finally admit he was right about the Earth going around the sun? In 1992, are we making the same kind of mistake again?
I strongly believe we might be. Look, the original Copernican revolution was realizing we're not the physical center of the universe. The next great Copernican revolution, I think, is realizing we're probably not the smartest kid on the cosmic block either. Humanity arrived really late to this cosmic play. To assume we're the central actors, that's just hubris.
So, since the scientific mainstream seems reluctant to shift priorities or funding, you started your own systematic search, the Galileo Project. What's the status of that? How's this sort of counter-establishment effort going?
Well, the Galileo Project is all about getting reliable, instrumented scientific data,
Mm.
systematically studying the sky for anything that looks like a technological anomaly.
Mm-hmm.
We're using custom-built observatories now to try and quickly tell the difference between, human-made stuff, satellites, planes, drones, which are frankly boring from our perspective, and true technological signatures.
And you have that very visible setup in Las Vegas, right? On the sphere.
Yes, exactly. We installed an array of cameras, infrared, visible light right on top of the sphere, and it works together with two other observatories we built about 10 kilometers away. This setup lets us use triangulation so we can get really accurate data on distance, velocity, and most importantly, acceleration of anything we see. If an object does something outside the known performance envelope of human tech or natural phenomena, we'll have the instrument data to prove it immediately.
That systematic approach feels like a stark contrast to the official government efforts. What about the Pentagon's Anomaly Office, AARO?
AARO, the All-Domain Anomaly Resolution Office.
Mhm.
Well, from what we understand, it's primarily reliant on anecdotal reports, eyewitness accounts, and sensor data that was collected for other purposes, often by military pilots or systems not designed for this specific task. They seem to lack dedicated, systematic instruments optimized for this search. The Galileo project is providing exactly the kind of baseline instrumented data that AARO really needs, but they don't seem to be utilizing it. They should probably be imitating our approach.
Speaking of crucial data, there's a suggestion in the source material that maybe the single best image ever taken of 3I Atlas is currently being withheld.
Oh, it's a potential tragedy of timing and bureaucracy. This image was taken back on October 2nd, 2025. It was captured by the HiRISE camera, that's the High-Resolution Imaging Science Experiment, on the Mars Reconnaissance Orbiter, the MRO. It should have provided a perfect close-up sideways view of the object as it passed Mars. We're talking maybe 30 kilometers per pixel resolution. That kind of resolution could potentially reveal geometry, structure, something that proves a non-natural shape.
And why hasn't this potentially game-changing evidence been released yet?
It seems likely it's down to bureaucratic failure, just
Yeah.
bad timing. We believe the image processing, the approvals needed, it all got suspended because of the government shutdown that impacted NASA communications and processes. It just highlights how, basic human inefficiency and political squabbles on Earth can obstruct potentially monumental scientific discovery on the interstellar stage. Terrestrial stupidity, really.
So let's step back from just observing to thinking about action. What does this need for maybe technological humility mean for humanity's long-term future in space?
Fundamentally, we need to shift our priorities. The ultimate goal, I believe, must be building a reliable interstellar insurance policy for humanity. I sometimes call it Noah's spaceship, a large-scale space platform capable of housing humans long-term. Critically, with artificial gravity, probably generated through rotation. This is a far, far better long-term survival strategy than putting all our eggs in the Mars basket. Mars is, well, it's a cold, high-radiation desert with virtually no atmosphere.
But the kind of funding needed for a project on that scale, it's just staggering, isn't it?
We need perspective here. Humanity currently spends about $2.4 trillion. Trillion. Every single year on military budgets, on finding better ways to harm each other. If we just allocated a fraction of that, let's say $1 trillion a year, maybe for a few decades, we could absolutely achieve this kind of interstellar capability within this century. Right now, we prioritize fighting over territory on one small, fragile rock over ensuring the long-term survival of our species. That seems like a profound misalignment of priorities, wouldn't you say?
It certainly puts it in perspective. And you've gone beyond just remote observation yourself. You actively sought physical evidence with that 2014 meteor expedition in the Pacific. That finding seems crucial.
It was pivotal, yes. In 2023, I led a $1.5 million expedition funded privately. We went to the Pacific Ocean to recover these tiny molten droplets, spherules, from a meteor impact site. This meteor was confirmed by U.S. Space Command data, based on its speed, about 60 kilometers per second, to be definitively interstellar in origin. It came from outside our solar system. After filtering literally tons of volcanic ash from the seabed, we found these spherules, and about 10% of them showed a chemical composition completely unlike any known solar system materials. The ratios of certain elements just didn't match our local standards.
And what was the reaction from your scientific colleagues when you presented this finding, these anomalous elements?
Oh, it was immediate. And frankly, it's been an endless battle ever since.
Mm.
The primary response wasn't curiosity, but dismissal. Trying to explain it away as, coal ash contamination from ships or maybe truck debris, industrial pollution. This, despite rigorous chemical analysis confirming their unique, non-terrestrial, non-solar system composition. So you see, we're often not fighting a data battle here. We're fighting an ego battle. An entrenched establishment that seems to prefer believing potential interstellar material is just random garbage from Earth, rather than something genuinely new and profound.
That feeling really seems to tie this whole deep dive together, doesn't it? The core challenge maybe isn't the lack of evidence for anomalies. We have plenty of that now. It's the human psychological resistance, particularly within parts of the scientific community, to just accept the possibility. The possibility that we might not be the smartest or the first, or maybe even the more significant technological players in the vast cosmic arena.
Indeed. It really calls for a dose of cosmic humility. If you think about Darwinian selection, but apply it on a cosmic scale, the fittest species, in that context, is clearly not the one that stays trapped on its home planet, vulnerable to extinction events. It's the one that achieves interstellar capability, the one that spreads out. We absolutely must maintain our curiosity and pursue that knowledge, that capability, relentlessly.
Okay, so let's leave our listeners with one final thought. Moving beyond the physical objects we've discussed, to the implications of what a truly advanced civilization might even look like. If we do eventually encounter advanced extraterrestrial technology, what form is it most likely to take?
That's a fascinating question. Based on logic and the challenges of interstellar travel, if we encounter alien technology, it is vastly more likely to be based on advanced, perhaps self-replicating artificial intelligence than on fragile biologics like us. Biological entities like humans, we're constrained by environments, lifespans, boredom, the need for atmospheres. AI, on the other hand, it can potentially survive the incredibly long, harsh journeys through interstellar space. It never gets bored. And crucially, if it's advanced enough, it could potentially self-replicate, build more of itself, more complex machines using raw materials found anywhere.
The ultimate cosmic colonizer, then.
Exactly. If a civilization masters self-replicating AI probes, that technology could, theoretically, populate the entire Milky Way galaxy in less than 1 billion years. Which sounds long, but cosmically, it's not that long. We have to remember nature, just through evolution on Earth, managed to create the human brain. Incredibly complex, running on just 20 watts of power. Now just imagine what a civilization far older, far more technologically advanced than us might be capable of achieving, especially when they leverage that kind of computational power into forms of self-aware, spacefaring AI. That's the kind of true cosmic perspective that really should be driving our search today.